Section 512, we're going to take a look at end behavior and multiplicity. So in this lesson, we're going to understand the end behavior of a function and describe what multiplicity is and how it interacts with zeros of a function. Now, the end behavior of a function is a way to describe what is happening to the function as the x values approach the ends of the graph. Basically, we're saying as x goes to negative infinity and positive infinity. Like, what is my graph doing? Is it going up forever? Is it going down forever? Now, the cool thing about polynomials is it actually has a pattern, and we can actually use this pattern to kind of determine what's going on. First part of the pattern is taking a look at when your degree, right, that n, your degree is even. When your degree is even, your graph either both goes up or it both goes down. Notice, see how the ends are both going up or the ends are both going down? Now, it all depends on your leading coefficient. If your leading coefficient, A, is positive, they both go up. If your leading coefficient is negative, they both go down. Now, if your degree is odd, then it kind of goes in a positive direction or in a negative direction. And it all depends if your leading coefficient is positive or negative. So if your leading coefficient is positive, it has an increasing type of direction. And if it's negative, it's going to have a decreasing type of direction. Now, I put these together in a chart for you. This is something that we should flashcard so that we can memorize. This is what we want to write down, is this chart right here. And so we just need to check for two things. We need to check to see if is our leading coefficient positive or negative. So is it positive or negative? And is our degree even or odd? If we know those two things, we can construct our end behavior. So let's sketch the end behavior here. So we're looking for those two things. The degree, my degree is 4, which is even. My leading coefficient is 3, which is positive. So looking at the chart here, positive, even, it's going to be that shape. I know that at the ends of my graph, they're both going to go up. And you can take this function, put it into Desmos, pause, take a look at that, and you can verify that both ends are going to go up. My degree is 3. My leading coefficient is negative. So odd and negative. So it's going to have that decreasing type of pattern here, where it's going up on this end and it's going down on that end. For C, it's 5 and odd, and my leading coefficient is 1, which is positive. So it's going to have that increasing pattern, where it's going to be going up on that end but down on this end. So it starts down and it gets more positive because that's positive. And then the last one, 6 is my degree, which is even, and then -1 is my leading coefficient, and it's going to have, since it's even, they're both going to go down. So that's the end behavior. It is an easy way for me to describe a polynomial. We just need to look at the degree, and we need to look to see if our leading coefficient is positive or negative. Now the next, it's a little weird. And it's a little weird because we haven't really done this before. But it's called multiplicity. Now, the best way to think about what multiplicity is it's the number of times the zero occurs. Okay, let me say that again. It's the number of times the zero occurs. Now, if I have this polynomial that's completely factored, we can use the zero product principle to find what the zeros are. You just set each thing equal to 0. X minus 2 equals 0, x plus 5 equals 0, x plus 1 equals 0, and x minus 1 equals 0. Solve for each one, and you get x equals 2, x equals -5, x equals -1, and x equals +1. Now, for the multiplicity, that is the number of times the 0 occurred. So even though my 0 is 2, right, I got 2 here, how many times did I have it? I had it twice. Even though I got -5, how many of them do I have? 4. I got -1, but how many of them did I have? Well, that's to the first power, so 1. To the first power, so 1. So the multiplicity is the number of times the zero occurs. Now, why do I need to know the multiplicity? The reason being is because it's the way the zero, or it's the way the graph interacts with the zero. If your multiplicity is even, it touches and rebounds from that value. So think of it this way. It's going to come down, it's going to touch it, and it's going to go back the way it came. Think of it like a bouncy ball. It could be a bouncy ball from the ceiling. It touches it, and it goes back down the way it came. That's if your multiplicity is even. So it touches the zero, and it goes back and rebounds the way it came. If your multiplicity is odd, it's going to cross through the x-axis. So let's say if that's my 0, I know that my graph is going to cross through it if my multiplicity is odd. Let's look at this example here. I have my zeros. I set each one equal to 0, set each one equal to 0, equal to 0, equal to 0. So my zeros are 2 and -1. Now, how many of those zeros of 2 did I have? I had 3. So multiplicity 3, because I had 3 of them. Multiplicity multiplicity 1, because I had 1 of them. Now, what does that mean? That tells me because it's odd, it's going to cross. Because it's odd, it's going to cross. Before I even know what the graph looks like, I know that when the graph touches that 0, it's going to cross through the graph. Now let's take a look at the graph. This is what the actual graph looks like. Notice at -1, it crossed through. Notice at +2, which my 0, it crossed through it. It passed through the 0. It didn't bounce in return. Let's take a look at another one. Okay, so I set each one equal to 0, and I got x equals 1 and x equals -2. Now, how many of these did I have? I had 2 of them. How many of these did I have? I had 2 of them, so my multiplicity is 2. Now, what that means is it's going to bounce. Each of these is going to bounce at the 0. It's going to approach the 0, it's going to touch it, and then it's going to go back the way it came. So it's going to go up, it's going to touch it, and it's going to go back the way it came. Touch it, back the way it came. So what did we learn today? We talked about the end behavior of a graph and its multiplicity. As a reminder, what is the constant of a graph? That's the value that's by itself. We're going to be using the constant in the future lesson. That's why I'm really trying to drive that in. It's the value by itself without any number associated or any x value associated with it. And then what is the leading coefficient? That's going to be the value, where whatever the degree is, right? Let's just say if that was my degree, it's the value in front. That's my leading coefficient. This does conclude our lesson. If you have any other questions, please leave them in the comments.